Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss how to remove a given key from singly linked list in Java. So here if we are given a singly linked list having 5 nodes, say 1, 8, 10, 11 and 16, where head points to the first node, and if suppose we want to delete a key having the data is 11, so currently if you see the fourth node has data as 11. Therefore, we need to write an algorithm which could delete this fourth node from the singly linked list. If you see, below is the algorithm for it. So let's go over to this algorithm step by step. So first we'll create a list node by the name current and it will point to head. So here current points to the head. Then we'll create a list node by name temp and it will point to null. So this temporary node points to null. Then we'll traverse the linked list in a while loop and we'll iterate the linked list in such a way that current should not be null and current data is not equal to key. So here current points to first node and it's not null, and current data, which is 1, is not equal to the key 11. Therefore the condition in while loop comes out to be true. So in first step what we'll do, we'll simply assign the value of current to temp. So current points to first node, therefore now temp will point to the first node. And in next step we'll simply traverse current to its next position by assigning current next value to current. So current points to first node and its next points to second node. Therefore we'll assign current next value to current. Moving ahead, here current is not equal to null and current data. So current data is 8 and it's not equal to 11. Therefore the condition in while loop comes out to be true. So here we'll simply assign the value of current to temp and current points to second node. Therefore the temp will point to the second node now. And we'll simply traverse current to its next position by assigning current.next value to current. Moving ahead, now again current is not equal to null and current data, which is 10, is not equal to 11. Therefore the condition in while loop comes out to be true. We'll simply assign current's value to temp, and here if you see current points to third node, therefore temp will now point to the third node. And now we'll simply traverse current to its next position by assigning current.next value to current. Moving ahead, so if you see current is not equal to null but current data, so current data is 11, which is equal to key. Therefore condition in while loop comes out to be false because current.data is equal to key. Therefore the while loop breaks out and we have traversed the current to the node which we want to delete. So here we will check whether if current is equal to null, and if current is equal to null, it means that we have traversed complete linked list and we haven't found the key. Therefore we'll simply return from the method. And if you see current is not null, therefore the if condition comes out to be false. So finally, in order to remove this node which is pointed by current and having value as 11, we need to break this link. So the temporary node which we have created earlier was used to hold the previous node position, so that once we found the node having the value as key, we can simply delete it through the temporary node. So currently if you see temp.next point to this current node, so we need to simply remove this link. But if we remove this link, then the node after current will also be removed. Therefore we need to assign temp's next value to current's next value. So if you see temp next points to current and current next point to the node having value 16, Therefore, we'll simply assign current next value to temp next. So it would look something like this. First, this link will be removed, and when we assign current next to temp next, it would look something like this. So now you can see temp next points to the current next node, and once this method get executed, then as current is a list node on the stack, it would be garbage collected, and finally when we rearrange the linked list, it would look something like this. So friends, this was the demo of the algorithm. So let's go to Eclipse and see the working code. We'll also see few of the edge cases there. So friends, in my previous linked list tutorials, I've created a class by name singly linked list, and this class has an instance variable list node by name head which holds the data into our singly linked list, and it has also a private inner class by name list node. So this class is responsible for holding the data into the singly linked list. And if you want to see the working of this code, you can watch my previous tutorials. So in this tutorial we will simply code the algorithm which we saw in the slide. So let's create a method public void delete node. So I've just created a method by name delete node, and it will take an integer value, say key. So based on this key, we'll remove that node which holds the value of key. So in first line we'll just create a list node by name current, and we'll assign the value head to it. Then we'll create a list node by name temp and assign a null value to it. We need to code an edge case which we not saw in the slide. So that edge case first, if suppose head data matched with the key, then we need to handle it separately. So we can write if. So in if condition we can say if, let's say current is not equal to null and current dot data equals key. So it means that we are handling the case where head data is matching with the key. So in that case we need to simply shift the head by one node. So to head we'll assign the value as current dot next, and we'll simply return from the method. So moving ahead, we'll now create a while loop which we saw in the slide, and the condition would be current should not be equal to null and current dot data should not be equal to key. So in first step we'll simply assign temp the value of current, because this temporary node will hold the position of the previous node to current, and now we'll simply traverse current to its next node. And after the while loop we'll give a check whether if current is equal to null, that means we haven't found the key in the singly linked list. So we'll simply return, and suppose if current is not equal to null, then current points to the node having the data equal to key. Therefore we need to remove that node. So the temp node is just the node previous to current, so we'll assign current dot next value to temp next. So what this will do, temp dot next currently points to current, but as we need to delete this current node, we'll simply assign current next value to temp next. Now in our main method, let's see it's working. So I've created a linked list which we saw in the slide, and if I run the program now, you can see the linked list has 5 nodes as 1, 8, 10, 11, 16. Now let's say we'll delete the node having the key as 11, and we'll again print the linked list. So if I run the code now, So here you can see initially there were 5 nodes, and after deleting the node having the key as 11, you can see the linked list become as 1, 8, 10, 16, and the node which was in between 10 and 16 was removed. So friends, this was the tutorial based on deleting a node with a specific key. I hope you have liked this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.